So we are going to discuss a numerical from the chapter vector, particularly on the topic divergence. So the question is, show that the vector field A, that is vector A, 2x plus 3y square I cap plus y minus 3z square j cap plus x square plus y square minus 3z k cap has neither source nor sink. So this source and sink is a very important term here in particular this numerical. So whenever I have this statement neither sink nor source, which means that the divergence of this vector field, divergence of vector A is zero. This is a very important statement. Divergence of vector A is zero for or when the statement says that it is neither source nor sink, which means that when I say it's a source, that means from a given source the vector field originate. So this is an example of a source. That means the divergence of this vector is positive or greater than 0. That means it is diverging. But when I talk about sink, that means the vector field will converge to a point, which means divergence of a vector A less than 0 or negative. So in this case, when they say this neither source nor sink, which means I have to prove the divergence of this vector is equal to 0. So how do I do it? Divergence of this vector to be 0. First I write divergence of vector A, which is the operator I del del x, j del del y, k del del z dot vector A. So what is vector A? I repeat again, I del del x plus j del del y plus k del del z. So this is the operator, and dot vector A. So I have to write down the vector A, that is, this is dot 2x plus 3y I cap plus y minus 3z square j cap plus x square plus y square minus 3z k cap. So when I have this divergence, that means all the terms will undergo a dot product. So remember, when I have this all the term, that means all the term in the first bracket undergoes dot product with the second bracket. Remember that during this dot product or during the process of divergence, I dot I yields 1 or I dot I gives 1, and I dot j or I dot k or j dot k, all this opposite, that means their angle is 90 degree, opposite unit vectors, they multiply in terms of dot product gives 0. So when I have the same unit vectors, their product in terms of dot product gives 1 and opposite gives 0. So I have I dot I, which is 1. So I have del x of 2x plus 3y. Then I have j dot j, so I have del y of y minus 3z square. I have del z of x square plus y square minus 3z. So when I have del x of 2x plus 3y, that means I have to do the partial derivative of the bracket 2x plus 3y. So all the x terms will be derivable, but the other terms will be constant, considered as constant. So for this term, del x will give me 2 of 2x plus 3y. And the second one, del y of y minus 3z square will give me 1. And del z of x square minus 3z will give me minus 3, which is 0. So that proves that divergence of vector A is equal to 0, which signifies that the vector A is neither source nor sink. This is a very important question.